So to get started, generic programming is a programming paradigm. And the purpose of generics is to abstract away, I would call it the shape or the constraints around a particular type at compile time. And so you're able to write simpler code that the compiler then does some work to figure out what the appropriate concrete type is. That's the whole point. And a large swath of useful utilities can be built using generics. A good thing, a couple of people mentioned the standard template library for C++. That's a perfect example. You can easily write reusable algorithms that are able to work with a lot of different concrete types. It also makes building certain data structures easier. So for example, it's much easier to build a generic map. When I say map, I mean like a hash map or a hash table. It's much easier to build a generic data structure like that, where you just say the keys and values have to have certain constraints rather than building a map of every concrete type to every other concrete type, which results in a lot of boilerplate code or resorting to code generation, which has been kind of classically in Go one of the solutions to not having generics in the language. So hopefully that makes sense as to why people would care about generics at all. And one of the key features of generics is you need some way to constrain this abstract type and let the compiler know some set of rules for how it's supposed to turn that abstract type into a concrete type later. And so what the language designers decided for Go is that there's something similar to that already in the Go type system, which is the interface. And there's this great slide from a talk by Frances Campoy, where he sort of visually describes Go's interfaces in terms of set semantics. So you can say, like, for example, if something satisfies the IO read writer interface, you can sort of imagine it as the intersection of both the IO writer and the IO reader interfaces. And you can think of interfaces in that way, and certain concrete types will satisfy an interface. And when we're building custom data structures, we do this all the time. We say that we can sort of abstract out what concrete types we want to work with by just saying that a type has to work with a certain type, has to work with a certain interface. And as long as that concrete type satisfies the methods of our interface, then it is that interface. And it's one of the unique things about Go compared to, say, Java, where you have interfaces that are explicitly implemented. Like when you describe a new class, you say it implements a certain interface. Go sort of does this on a structural level, which makes it a little bit easier to use and unique. And so that's what the Go language designers decided was the best approach to accomplish generics, which was basically to say, well, we already have interfaces that describe constraints pretty well. So the approach to implementing generics is really to just expand the semantic capability of interfaces to also support lists of types or lists of other interfaces that describe sort of the trait of the concrete type that the compiler will deduce later on. And that's important because this means that the generics implementation in Go will be completely backwards compatible with all the code that exists out there right now. I think there's a lot of confusion in the community because this tool is called Go2Go, and the code examples are .go2 files, and people have often described this as Go2 in the past. And so this draws, you know, horror comparisons to Python 2. If you read the RFC, which is now open to actually implement all this stuff in the language proper, you'll see that really the timeline for this stuff is probably going to come about within the next year or so, probably Go 118 or 119. And the fact is there probably won't ever be a Go 2 in the foreseeable future, certainly not just for the generics implementation. So what we'll look at in the code are some of these takeaways. Kind of on the base level, the syntax change for describing generics in Go is this extra set of square brackets, where for functions, for example, you can say I have a function f that works on a t of a. Sorry about that. Any is the type constraint that's predefined in the language. And I'll jump down here. There's two pre-declared generic types in this proposed implementation. Any is comparable to the empty interface. So any corresponds to just any type constraint. There's one other pre-declared type constraint that we'll see in the code, which is comparable. And it's very straightforward what that means. It just means that you can check equality or inequality between two types. So that's what a type parameter looks like. And you can also have a type parameter on a type. And this is useful for, like I said, building generic data structures. And constraints are the key idea. So when we look at the code, you'll see how we'll look at 3 code examples to kind of see how generics are used to build up a useful abstraction. Is everything clear so far as why this is useful and kind of the very high level of the implementation?
Yeah, Damien, this is making sense. I did notice, and it sounds like a couple other folks are having a little bit of difficulty with your audio at certain points. I don't know if it might work to turn off video and stick with audio, at least just while you're screen sharing for now. We could give that a shot, but it's kind of cutting in and out a little bit.
Okay, sure, I'll do that. I got a pop-up that said my internet connection was unstable, so that
okay. Sometimes that helps. And folks, if you could maybe type in the chat, just see if that helps us or not. But at least for now, while you're going through the slide deck, that might work.
Yeah. Okay. Okay. So, does anyone have any questions before I continue?
So hi, Damien, this is Chris. Does comparable allow the greater or less than comparable as well, or just not equality? Is that all it does?
As far as the specification describes, it's just equality and inequality.
Interesting. Okay, thanks.
So to continue, there's a to show you guys kind of how I'm running this. Essentially, but to play around with the generics implementation, you can do so right now. Essentially, what you do is you download the Go source repo from GitHub, and then you compile against a certain branch, which has all these Go generics features implemented already. And then you have to fiddle a little bit with how you run things. You have to set a go-to path, and you have to use a Go root even in module mode, and I won't get into the details. All this code will be linked in a repo that I'll share, so you can certainly play around with it and definitely do so, because that is the best part, is breaking things and seeing why things don't compile. So with that, I will jump into a little bit of real code. So here's like the hello world that I've seen in a couple places. This I think is pulled directly from the specification document. But basically, to read through the code, we have a function print that operates over any type. It's unconstrained. And if we run it, you can see that it will print this slice of strings and then slice of integers as well. And I will see if I can run it. And it should run. One thing one thing that I'll mention as well is that pre-declared any type. It's not included in the draft specification, but there is discussion on the language team for down the road, once the generics implementation is done and it's part of the language and people are kind of used to it. It may be the case that the any type constraint can be used anywhere you would typically use an empty interface, because they're semantically the same thing. So that's one thing when you're looking through the generics code, if you see any, you can mentally think of it as an empty interface. It works the same way. So I will open some code examples now. So this is one thing. So all of these code examples, I'm going to include them in the repo that I'll share just so that it's easily accessible. But these are actually all in the Go generics development branch of the source code that you use when you're building this Go-to-Go tool. So these are all available, and you can actually run all these tests and play with them, and it's a really interesting thing to do. So the first thing we'll look at is this constraints package. And this is sort of, the language authors have described this as kind of, this may be a useful package to include with the language standard library. Similar, obviously not in scope, but similar intent maybe to that are broadly applicable. And so what this looks like is you have an interface like you would expect, but instead of an interface describing just methods, it can describe lists of concrete types now. And so it's pretty straightforward when you think about it in that way. The ordered interface constraint describes any concrete type can work with a greater than or less than, greater than or equal, and so on. These different operators. Same thing for integers. You can kind of broadly accept anything into either signed or unsigned, and so on. So this is the core idea. Basically, and this is comparable maybe to Rust traits, to any other generics implementation in another language you can imagine. It's useful for constraining the behavior without talking about methods. You're just talking about which concrete types are acceptable. So do constraints make sense to everybody?
They do. So the ordered implies equality based on the any, just because
it does.
Is that right?
Correct. So ordered implies, so ordered by implication, anything that satisfies, because all these concrete types satisfy the comparable, it's not written here, but that's correct.
What are the implications with this user interface now in terms of like, you could define a function that accepts just a parameter that's ordered, for example, without using generics now? Is that true?
Well, so we'll see in the code the parameterized type can be a constraint, if I understand the question correctly.
Yeah, maybe see an example will help. So, thanks.
So it would, so for example, if we look at the, let's see where that mean. So if this parameter t, so in order to be able to refer to this slice of t, for example, the constraint has to be defined first in the square brackets where the type parameters are placed, if that makes sense.
So sorry, just to confirm, would the constraint defined only be allowed as that type parameter, or can we pass it in as like a parameter argument? So like if it was a slice of ordered, are constraints allowed in that sense, or do they need to be defined as in like the brackets?
Right. Okay, so now I understand the question. No, so in the current design draft, they have to be specified as type parameters first, and then they can be referred to in the actual arguments.
Gotcha.
If so, there is, so I guess the correct answer is to say it depends, because the compiler is able to perform type inference. So if you pass I don't think you can pass a parameter that just describes the name of a type constraint, but if you pass a concrete type that does conform to that constraint, having to define the type parameters first. That's a good question, though.
Are you allowed to mix methods in these type interfaces as well?
What do you mean by mixed methods?
So you have like the ordered interface with type int and the rest, and then you could also say you could also add method definitions to that interface. Is that allowed, or can you only put types on one interface and methods on another?
Yes, I believe it is. I think you can add both type lists and interfaces to. I'm sorry, you can add type lists as well as methods to an interface.
Okay.
Yeah.
And that becomes a part of the contract, right?
Yes, exactly.
Yeah.
Yep. And that's so in the way back like 2 years ago when the very first draft of the generics proposal was put out, that was part of the explicitly that was an explicit part of the syntax. Like you had to define what you would define the type lists as part of an interface, and then you would define also a contract, and the contract would be the methods. And that's actually we were talking about C++. That's what the C++ 20 contracts proposal defines, where you sort of if you want to constrain a type on different templates, you have to specify that as a contract with the contract keyword. And in the initial design, the Go implementation also had a special contract type or keyword. I don't remember which, but that was decided to be relaxed and just all put into an interface. So yeah, you can put type lists and methods.
And that is especially interesting, right? Because you could put a function there in the interface that the types don't implement, correct? And then would that then cause a compile error?
Yes, I believe that would cause a compiler error, but that's an interesting case. So now let's look at a use of the constraints. So this is something as Go programmers we've done a million times, is define max and min for an integer or float or anything else. So here we're basically defining a generic max and min over anything that is ordered in terms of the constraints. And so hopefully this answers the question about whether you can use a interface constraint directly in a parameter list without having defined it first. And I'd have to check, I don't know how powerful the type inference in the compiler is going to be for this. But in the draft design, I believe they cover most of the cases of how the type inference works as far as what it's able to deduce. But I think you do have to type constraints into the parameter argument list before you can add them later on. But that was a good question. So self-explanatory, and I think slices, yeah, okay. So then building on, we have this list of constraints. We've defined what max and min mean in terms of those constraints. Now we can look at something a little bit more useful. So these are basic generic operations over slices of any type of element. And there's an interesting sort of case study in the draft document where they talk about how you could produce a compiler error by adding something to an interface that's not possible. For example, you can't hash a slice. Slices are not comparable to each other directly. So if you tried to define an interface constraint required that two generic slices were comparable to each other, it wouldn't work. It would produce a compiler error. But here is a list of useful generic functions over slices. I guess at this point, so now that we're kind of at the level of abstraction where most of this stuff would be used, are there any particular data types or anything that you all would find useful to look at? So one thing that they provide as far as examples, we've already looked at both the base constraints package as well as the min and max stuff. This is slices, but there's also channels. There's a graphic algorithm implementation, some sorting stuff, maps, metrics. I don't find all that interesting. And then there's also proper sets, which you may be familiar with from a language like Python. So I guess I'll turn it to you all. Are there any other questions about this sort of base building blocks? Or are there any data structures or algorithms that you all would be really interested in looking at in more detail?
I mean, we can go to channels. Would be a neat one to kind of jump into. I'd be curious. Are these are examples that come from the Go? Is that what you said, the repo there?
That's correct. Yeah. So if you look in the branch for the Go development, it's in the it's under command and Go tool, and then it's in the test data folder. There's an
awesome
Go root that has all these examples. And as far as the real world utility of generics in Go, the channel implementation is one that where I work, we would have found this very useful, because our line of business is working with IoT data, and we essentially build a real-time streaming graph database. It's built on top of Cassandra and some other technologies, but we have basically an internal MapReduce platform that we built in Go. And it works really well. It scales tremendously. But because we have different data types that we have to work with, unfortunately, a large chunk of our MapReduce streaming sort of data transformations necessarily end up being from empty interface to empty interface, and we have to do type assertions. And it's a little bit annoying in that way. And I think if we had generics implemented when we built that system, it just would have been shorter and it would have been clearer. We would have caught more errors at compile time rather than runtime. So that's one use case that I think is very practical, is not having to resort to using empty interfaces where we need a little bit of dynamism in the type, but we really like to constrain it to certain things. Another place is people talk about error handling, but we haven't found that to be particularly onerous. The Go error handling mechanism is pretty well understood, and I think for us that was not a problem. But definitely having generic channels would have been useful in our case. So this is one that hits near and dear.
What's the impact of this on the entire Go library, the Go standard library? Does this mean for years to come, things to be rewritten in every new version and everything?
I don't think so. And I think that's part of the reason that the process has been so slow going. I think off and on for several years, people have proposed different generics implementations in Go, and it has never really stuck until now. I don't think it will come down to the language designers to decide how much of it gets put into the standard library and what gets rewritten, if anything, as far as those standard packages. But I think probably this list of examples, I mean, this is the only ones they have so far. And these are probably the areas where it seems the most useful, like being able to build generic container data structures is probably useful. Being able to have set semantics, being able to sort of have better definitions of how certain types are comparable to each other is useful. But I don't think it'll be the case that everything ends up being more complicated. And someone asked a good question in the prior talk that I gave on this, which was, is this going to make Go code harder to read in the wild? And in some sense, yes. I don't think it'll make it harder to read, but I think it'll mean there will be more to read. Because if you, for example, let's say this was an open source package called generic channels or something like that. And I didn't necessarily understand what the, say there was an extra constraint on this element type. Obviously the type is just named, but I would have to go and read that source code to understand what the constraint means in terms of its implications. So that will definitely be the case when you encounter generic Go code in the wild. You'll have to do a little bit more reading if you have to literally go read what the abstraction is referring to in terms of what concrete types or methods are accepted. And that's the part of the trade-off. I mean, that's the case if you look at Java code or Rust code. It's highly generic. Or if you look at C++ templates, like you just have to browse around a little bit more to understand the implementation. But that's a good question. I think that's a large part of the concern in the community is how much of a deleterious impact is it going to have on one of the things we love about Go, which is that it's very easy to read, and you can read a page of code and completely understand what's happening.
May I make a comment?
Of course.
Yeah, so I look at this a lot like the standard template library, where in C, we had to build a lot of these things like linked lists. It was a pain in the butt. We had to make it ourselves or buy some sort of library that would do it for us for all the types that we needed. Mm-hmm. The template just added that opportunity of all these things that we had not had the opportunity to use on just an off-the-shelf basis, which was great. The other part is that Go's going completely reverse compatible with this, right? So the existing code will work, so it shouldn't look any different. But I will give you the word of caution. If you look into a standard template library and try to read some of the templates, it's rather ugly stuff. And I think that's what Damien's really is trying to nail on here, is that it's not going to impact the Go code that we've written so far. And it doesn't have to impact even how we write it tomorrow. But if we want to look into those generic types, how they're defined, it's going to be a little bit different than what we're used to. So we will have that. I look at it as an opportunity. Thank you.
Yeah, I wonder if, it's kind of similar to some of the like Go routine, Go channel stuff that's implemented today in a lot of the third-party packages, right? Like if you go and you look at it, it might be a little bit daunting or confusing or complex. But from like the user's experience of, pulling that in and actually using it, right? It's fairly simple. And I think it was Robert Gressimir, I probably butchered his last name, in the last GopherCon, right? Kind of showed like what the user would experience using this function, right? They were trying to get to the point where it looks just like another normal function call. So
yeah, absolutely. And that's really the work, the harder work is going to come down to package authors who are maybe just in terms of convenience, it's easier to build one data structure that operates over constraints. And you have to do the work of writing all that stuff out and making sure the constraints are proper in terms of their scope. But then from the end user's point of view, when they import your package, they don't see any of that. They just see
right.
Method that works. It's a good question. Are there any other snippets of this generic Go code that we want to look at?
Since we looked at channels, I could see looking at maps next, just to see what that looks like in practice.
Yeah, and this is one that we've also had to write a lot of boilerplate at work.
Yeah, just getting a slice of all the keys or a slice of all the values.
Yep.
Do that all the time.
Yeah, and I appreciate the amount of time the language authors put into making, I don't know, just making the different implementation decisions very reasonable and easy to understand why. The draft document is a bit long, but it's definitely worth reading all the way through. And I also really like, I put in the README here, their comparisons to the generic type systems in other languages. And I also added a link to, there's a paper and a recording of a Zoom discussion with Phil Wadler, who helped inform kind of the theoretical basis behind the generic implementation for Go. The paper is called Featherweight Go, and it's related to his work from gosh, 15 years ago now, probably, on featherweight Java, which informed kind of how the implementation works for Java. And they're quite different, but if you're interested in the theory behind how this implementation was sort of come to, it's really interesting. And Go's generic implementation is actually closer in spirit, I think, to Rust's than Java's.
Do you know, are there planned additions to the standard library that start to incorporate generics? And are they advertising some of those yet?
That's a good question. The only thing that I've seen is they mentioned that this constraints package is probably something that will end up in the standard library. But as for what will be written in the constraints package, it's not clear yet. I think they're just saying that anything that ends up in the standard library will be, they'll probably only want to include things that are very broadly applicable. Now, I don't know if that means they'll incorporate generics for, say, errors or channels, for example, just comparison operations. I don't know. It's not clear yet.
I imagine there'd be pretty good open source presence for a lot of the common things that we do, right? That's going to happen pretty quickly. And then whether it gets incorporated or not to the spec or into the standard template is up to the designers and community, I guess.
Yeah, that's a good question. Yes, I don't really have anything else that I really wanted to hit on. I will share the link to the README because hopefully those links are useful. You can download the working branch for this and really play around with the code. And then like I said, the draft design document is really worth a read to understand kind of the approach to this and why it's taken so long, and also why they want to do it very carefully. And one thing I really appreciate is that it's fully backwards compatible, because there were.
That's a comforting thing for sure.
Yes, absolutely. Any just being able to know that we're not going to have any breaking code is useful, because that's one thing that I've been using Rust long enough that having to use very good automated tooling to fix things, but it can be kind of daunting when you do have breaking changes. So looking forward to this being a very boring release when it actually does happen.
For sure. Well, thanks for running through that, Damien. That was super helpful. If you don't mind, how about we switch back from the screen share, just so we can do the panel view, and folks feel free. I know a lot of folks kind of voiced questions as we go, but if you have any other thoughts, any other questions, feel free to go ahead and bring that up now.
So currently this is cross-compiled, right? So we're compiling the go-to generic stuff to go underneath at the moment. That's kind of how it's working. Is that what I understand?
Yes, exactly. One thing I didn't have time to cover today, but is very useful and interesting, is if you go, if you download the branch, you build the go-to-go tool. If you go into those example test data packages here that I've shown, if you run those tests, what will happen is it will generate, it'll code generate the actual Go output, and it'll show you both the package file and the test file. So it's interesting to see what the concrete implementations are, because it's still very readable.
That's pretty awesome. I didn't know that you could see the output. Well, of course you can, right? So you said that 1.18 maybe is the target for is what they're thinking, or is this that was just a guess, or maybe a year?
Yeah, I think so, because they said it was in the RFC, and there's a long list of dozens of comments now. I think they said that it looked like it would be probably 2 major point releases away. So that would put it about a year from now.
Awesome. I see somebody put it in the chat. Thanks, Damien.